Hi everybody, in this video, let's look at combinations. In combination, the order of arrangement is not important. In the previous video, I shared with you about the permutation, which the order of arrangement is important. Okay, let's do a quick revision. Let's say, if you have 1, 2, 3, 4, you have 4 digits. You want to use 2 of them to form a code which consists of 2 digits. So let's say the first digit you choose is 1, then followed by 3. Okay, second time you choose 3 first, followed by 1. Is these two the same code? No. These two are totally different code, right? So they are different code. In this situation, we say that the order of arrangement is important. But how about, let's say, if you have 4 people, 4 students, let's say, A, B, C, and D. You want to form a team which consists of 2 students. You choose A first, followed by B, or B first, followed by A. They are actually the same team, right? So in this situation, we say that the order of arrangement is not important. So we will be using combination for this part, and this, the order of arrangement is important. We will be using permutation for this situation. Okay, so in this video, let's focus on combination. So before I show you some example, we need to know about this NCR. Okay, still remember NPR. You have N object, you want to choose R of them, and this is permutation. The order of arrangement is important. Normally, it will involve like forming a code, forming a password. Okay, so this is equal to n factorial divided by n minus r factorial, right? Okay, so today we are looking on combination, which the order of arrangement is not important. We will be using NCR. Same thing, we have n object. We want to choose R from them. Okay, so this formula is almost the same like this one. N factorial, n minus R factorial. But since the order of arrangement is not important, we need to divide it by R factorial. Okay? Now, let's look at these few properties. So just be more careful. This and this the same, but because in combination the order of arrangement is not important, that's why we need to divide by R factorial. Okay, now let's look at the first one. NCR is actually equal to NCN minus R. So before I give you some example, let me show you why this two is actually the same. NCR, okay, this one I don't have to do it anymore because it's actually equal to this, right? Okay, let me show you NCN minus R. Okay, so it will be n factorial over n minus this factorial, right? N minus R. The whole thing here, factorial. And then divided by n minus R factorial. Okay, this is this. Let me erase this one first. Okay, and then for this part, we take n minus R. N minus R, which is this part. Okay, and then divided by R factorial divided by n minus R factorial. Okay, let me proceed it. You will notice that these two are actually the same. Let me open up this parenthesis. It will be n minus n plus R factorial and n minus R factorial. Okay, so n minus n will give you 0. Eventually, we will only have R factorial, n minus R factorial. You see, these both are actually the same. Okay, let me give you more examples so that you understand more about these properties. 10C7 is actually equal to 10C. 7 minus 3, sorry, 10 minus 7, you will get 3. Okay, you can press your calculator. 10C7. How do we press 10C7? You will see that NCR, this is in yellow color. So if you want to press this NCR, remember to press the shift first so that your calculator know that you want this, not this. Okay, 10C7 equal 120. Now I change the 7 to 3. You will still get the same thing, 120. Let me give you another example. Let's say you have 7C5. Try to guess. Is equal to 7C what? 7 minus 5, you get 2. Again, you can use your calculator to help you to check. 10C5 is equal to 21. I change the 5 to 2, you will still get the same answer, 21 as well. Okay, so I think this property you should be no problem now. Okay, so this NC0. NC0 is actually the same as, is actually equal to 1. NC0 is equal to n factorial, n minus 0 factorial, and 0 factorial. Okay, so this is n factorial. N minus 0 factorial is actually equal to n factorial. 0 factorial is equal to 1, right? In the previous video, I told you about this. So this is actually equal to 1. So eventually, n factorial, you can just simplify them, then you will get 1. Okay? Now, NCN is actually equal to 1. I think this one should be no problem. You have n object, you want to choose n of them. There is only one group you can form, right? Okay, so this one, the last one. NCR is actually equal to n factorial, n minus r factorial, n divided by r factorial, right? Okay, so now this is actually, okay, let me move this whole thing go up first. Or how about I write this first? This is divide, right? Divide. So 1 divided by r factorial, I bring it to another side, it's actually become multiply. So this is actually equal to NPR. Okay, so now I think it should be no problem for these 4 properties. Let's look at few examples on this combination part. Let's look at this question number 1, example number 1. In how many ways can 6 prefects be selected from 9 students? Okay, number of ways. Here we will be using combinations because the permutation is not, the order of arrangement is not important. So total we have 9 students. We want to choose 6 of them. 6 from them. So what do you need to use your calculator? 9 C6 is actually equal to 84. This one I think it should be no problem, right? I showed just now how do we key in this 9, shift first, then press this, you will get C, and then 6 is equal to 84. Now let's look at example number 2. In how many ways can 12 people be divided into 2 groups consisting of 8 people and 4 people respectively? So total we have 12 people. We want to divide them into 2 groups, which is 8 people, and second group is 4 people. Okay, number of ways. First group, 8 people. So from 12 people, we want to choose 8 from them. So it will be 12C8. Okay, the second part you need to be more careful. Total we have 12 people. After choosing 8 people from them, we only left 4 people. So this is not 12, but 4. 12 minus 8, you will get 4. After choosing 8 people, only 4 people left. We want to choose these 4 people to form the another group which consists of 4 people. Okay, now just press your calculator. 12C8 is equal to 495. 4C4 is equal to 1. So the answer will be 495. Okay, now let's look at quick example number 3. A teacher wants to choose 5 students from a group of 5 boys. So we have 5 boys and 4 girls. We want to choose 5 students from them. From the total 9 students, we want to choose 5 from them. To form a team of cheerleaders, find the numbers of ways the team can be formed if no conditions are imposed. So for the part A is actually pretty simple. Number of ways. No conditions are imposed. So total we have 9 students, right? So from 9 students, we choose 5 from them. 9C5, which is equal to 126. Now let's look at part B. There are more boys than girls in the team. Given that the team must consist of 2 genders, means that it cannot be all boys or all girls. The team need to have girls and boys. So since the condition is more boys than girls, so total we only need 5 students. So more boys, it can be 3 boys, 2 girls, right? How about 2 boys, 3 girls? Cannot. They cannot be accepted because here request more boys. 2 boys, 3 girls. Now girl is more than boy. We don't want this. We want more boys. So it must be 3 boys, 2 girls, or 4 boys, 1 girls. And always be careful. The sum of the number of boys and girls must be 5. 3 plus 2, you get 5. 4 plus 1, you will get 5 as well. So how about 5 boys, 0 girl? We cannot accept this because the question says that the team must consist of 2 genders. Okay, now we can start to calculate the number of ways. Let's look at this one first. 3 boys, 2 girls. Total we have 5 boys. 5C3, 3 boys. 2 girls. Total we have 4 girls. 4C2. Okay, this is for this situation. All this, right? So we have to use plus here. 4 boys. So 5C4 times 4C1. Okay, so just press your calculator. 5C3 times 4C2. This will give you 60. 5C4 times 4C1. This will give you 20. So total we have 80 ways. Okay, now let's look at example number 4. How many triangles can you form from the vertices of a heptagon A, B, C, D, E, F, G? So we have 7 vertices here, heptagon. 1, 2, 3, 4, 5, 6, 7. So to form a triangle, we need 3 vertices, right? Number of triangle is equal to, from the 7 vertices, we want to choose 3 of them to form a triangle. So it will be 7C3. which is equal to 35. Let's go to B. How many of triangle form have A as one of its vertices? So A must be chosen in this time. Number of triangle. So before we calculate, we know that the answer here must be less than this one, right? Because this, for part A, no condition is imposed. For part B, A must be one of them. So 1C1, A must go in. And actually, now we only left two vertices because A must be go in. So we must choose A. So we can choose another two from 6 vertices here. So it will be careful, no more 7 because A is already chosen. So now we left 6 for us. So it will be 6C2. So 1 plus 2, you will get 3 vertices which can form a triangle. 1C1 times 6C2 is equal to 15. Okay, now let's look at example number 5. The table shows the frequency distributions of the houses of 15 school districts. So we have red, green, blue, yellow. Okay, so we have 2 districts from red house, 4 districts from green house, and so on. A team of 5 districts is to be formed to represent the school in an athletics championship. If the school team must have exactly 2 from the yellow house, and the rest you can choose from red, green, or blue, but total we need 5. Okay, these are all important information. We need to pay attention on it. Calculate the number of ways the team can be formed. Okay, so we think about the condition first. 2 districts from the yellow house, exactly 2 districts from the yellow house. So it will be 6C2. Okay, now total we need 5, right? Since we already have 2 here, so we need another 3. And this 3 is from this. 4, 3, and 2. So total here we have how many students here? 9. So it will be 9C3. 6C2 times 9C3. So the answer is 1260. Let's try one more example. Okay, so now let's look at the last example, example 6. The 5 letters code are to be formed from the letters in the word morality without using any letters more than once. Means that every letter only can be used once. Find the number of 5 letter code that can be formed. This is talking about code, means that the order of arrangement is important. Now let's look at part 1. There's no restrictions. So how many letters we have here? Number of code. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 letters. We want to choose 5 letters from 8 letters. And the order of arrangement is important, right? So we will be using P. 8P, 5. 8P5. Oh, let me press again. Okay, so the answer is 6720. 6720. Okay, let's look at part 2. The code must have the letters Y. Must have the letters Y means that the Y must go in. So let me explain this way. 1, 2, 3, 4, 5. I'm going to show you 2 methods here. The first method, I just assume that the Y is over here. Okay, why already chosen? Now we have how many letters left? 1, 2, 3, 4, 5, 6, 7, right? So it will be 7, P, 4. Okay, so number of way is equal to, this is y, so you can just write 1, or you can write 1p1 times 7p4. But this is not the final answer yet, because the y can be here, right? It also can be here as well, and so on. So total we have 5 places for y. It can be here, 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 or here. So we need to times 1, 2, 3, 4, 5. Okay, just press the calculator. 7p 4 times 5. You will get 4200. This is one of the methods to solve this type of questions. So second method, I'm going to use a combination together with the permutation to help us to get the answer. Number of way, or you can say number of code. Okay, first, I don't want to think about the arrangement, so I will be using C first. 1C1. This is for Y. I choose Y go in. Then I left 7 letters. 7C4. You will notice that these two C means that I do not consider about the arrangement. The arrangement is not important. And now I actually get how many groups I can form. But every single group, there are how many arrangement? Since we have 5 letters, right? It will be 5 factorial. Okay, you try to press your calculator, you will get exactly the same answer. $4,200. Okay, let me explain it again. This will give you how many groups. The order of arrangement is not important. And why do I multiply by 5 factorial? Because this is talking about code, right? So the order is important. So since we have 5 letters, so the order, the arrangement, the number of arrangement will be 5 factorial for each group. Okay, so the answer 4200. No matter you use this method or this method, you get exactly the same answer. Now let's go to part 3. The code must have all the vowels A, E, I, O, U. Okay, let me choose the vowel first. So how many vowels we have here? O, A, and I. So I have 3 vowels over here. So in this part, I'm going to use combination together with permutation to help me to get the answer. 3C3. This is for the vowel. Okay, since I'm using C here, the order of arrangement is not important. 1, 2, 3, 4, 5. I have 5 consonants here. 5C, 5C2. Why do I put 2 here? Because I want to form a 5-letter code. I already have 3 letters over here, so I need another 2 letters. Okay, this is C. We do not consider about the arrangement. Now I start to consider the arrangement. Since I have 5 letters, I want to form a 5 letters code, and all of them, they are different letters, so it will be very easy. 5 factorial. Okay, press the calculator. The answer is 1200. This will give us how many groups. And in every group, we have 5 factorial arrangement. So we take this times this. You will get the answer 1200. Let's try the last one. The code must consist of all the vowels which are to be next to each other. So you will notice that here is consists all the vowel, and we have more condition here. We need to consist all the vowel, and all of them must be next to each other. So we know that the answer for part 4 will be definitely less than this. The beginning part is still the same, how many group. So we have 3, C3 for the vowel, and then consonant 5, C2. But at the back here, slightly different. Since that the vowel must be together. So this I consider as, I tied them together. One I consider it as one unit. So consonant, it can be separated. So now we have 2 units here. Okay, because this I want to tie them together. They must be always be together. So here I'm going to multiply 3 factorial, not 5 factorial, but 3 factorial. And don't forget, the 3 of them, it can be changed. Their places can be changed. For example, O A I and I O A, and so on. Since we have 3 letters here, so it will be 3 factorial. Okay, now press your calculator. The answer is 360. Okay, that's all for this video. Thanks for watching. See you next time. Bye bye.